All right, let's dive into something that can go from 0 to a 5-alarm fire in like seconds: VMware storage. So, what we're going to do here is build your pro troubleshooting playbook. So, when that fire drill inevitably happens, you're the calmest person in the room.
Oh man, we've all felt that pit in our stomach. That dreaded message pops up from a user. Everything's slow. Is it the storage? And just like that, all eyes are on you. It's the default blame game, and it can send you spiraling down a rabbit hole of chaotic checks and pure guesswork. But what if you had a system, a method to the madness? Well, that's exactly what we're going to do. We're going to take that chaos and forge it into a clear, methodical process that puts you back in control. And it all starts with a simple framework. The secret, really, is that you can simplify pretty much any storage problem by starting with just 2 simple questions.
Yep, you heard me. Just 2. Forget about the hundreds of metrics you could be looking at for just a second. If you can master these 2 questions, you are already halfway to finding the solution.
Okay, so here they are. First, on the left, is the problem in the storage system itself? The array, the disks, or is it somewhere in that complex path to the storage? Just asking that one question immediately splits your entire investigation in half. And second, over on the right, is the impact availability, meaning you can't access data at all, or is it performance, where everything is just painfully slow? Knowing the difference is huge. It stops you from chasing latency when you've actually got a complete outage, and of course, vice versa. So how do you actually apply these questions, right? We use a mental model that I call the layer stack. I want you to think of it like your roadmap. It forces you to check things in a specific, logical order, which prevents you from doing what we all want to do: jump straight to the bottom and blame the storage array. All right, let's walk through it from top to bottom. We always start with the workload symptom. What is the virtual machine or the application actually experiencing? Then we move down to the vSphere signals. What are your data stores, your alarms, and your cluster health telling you? From there, we check the host path, the network, the HBAs, the multipathing, and only then, at the very bottom, do we finally look at the storage backend itself. This top-down approach is absolutely crucial. It stops you from getting lost in the weeds. Okay, theory's great, but let's see how this plays out in the real world. Your approach is going to change depending on whether you're dealing with vSAN or more traditional external storage. They leave totally different footprints when things go wrong. If you remember one thing from this whole explainer, make it this quote right here. Because vSAN is a distributed system, its problems usually show up as cluster-wide behaviors. If one VM is slow, chances are all of them are feeling it. But external storage issues, they often show up as these weird partial problems, like some hosts can see the data store, but others can't. So when you're looking at vSAN, you've got to think of the cluster as one big organism. Look at the overall health status. That's your pulse check. Are you seeing policy compliance issues? Basically, are your objects meeting their own resilience goals? Keep an eye on capacity pressure, and this is a big one: look for high resync or repair activity. A really busy rebuild can make the whole system feel sluggish, but it's often a symptom of healing itself, not a new failure. Now, with external storage, your focus completely shifts to that end-to-end path. First question, is data store accessibility consistent across all your hosts? If not, stop there. Then you dive into pathing and multipathing. Has a path gone down? And finally, you check the health of your specific protocol, whether that's network-based like NFS and iSCSI or fabric-based like Fibre Channel. So let's boil this all down into a quick cheat sheet. For vSAN, the symptom is that cluster-wide behavior. You're going to be watching cluster health, and a super common culprit is a resync or just simple capacity pressure. For external storage, the symptom is often that partial visibility. You're watching pathing like a hawk, and the most common culprit is almost always an access control mismatch, like zoning or masking. Okay, so since those external storage problems are so often about that tricky path, let's dedicate a whole section to a step-by-step process just for that. Let's call it the troubleshooting ladder. Seriously, follow these rungs on the ladder, and I promise you will find the problem. Start at step 1. Validate visibility across all your hosts. If it's not consistent, stop right there. Your problem is almost certainly in step 2 or 3. Step 2, check the access controls, zoning, masking, exports. This is, hands down, the most common root cause of external storage problems. Step 3, hunt for host configuration drift. Is one host set up differently? Step 4, verify your multipathing is healthy. And only after you have checked all of that do you get to climb to step 5 and finally start blaming the backend array. All right, we've spent a lot of time on how to fix things when they're on fire. But the real pro move, right? It's shifting your mindset from just fixing problems to actually preventing them in the first place. And listen, when I say optimization, I am not talking about tweaking some obscure kernel setting or some advanced knob you found in a forum. It is all about rock-solid operational hygiene. It's about mastering the basics and keeping things clean and simple. So where should you put your energy? It really comes down to three key areas. First, make sure your storage traffic is stable and, ideally, dedicated. It shouldn't be competing with other traffic. Second, be honest about your capacity planning and make sure your storage policies are realistic for your hardware. And third, make your maintenance predictable. You need verification checkpoints before and after every single change you make. So what does that actually look like day to day? It's just a simple, repeatable routine. Daily, just glance at your health scans and any red alarms. That's it. Weekly, take a look at the trends in your capacity and latency to spot that slow degradation before it becomes a crisis. And maybe most critically, during any change window, you perform a before and after verification to be absolutely sure you haven't introduced a new problem. Okay, let's put it all together. This is your playbook. This is your go bag, your actionable takeaway for the next time that emergency call comes in. Let's start with what not to do. The single biggest mistake is skipping scope definition. You have to know, is it one VM or the whole cluster? Don't confuse the symptom, like high latency, with the actual cause. And please, don't ignore the access controls or forget to check for configuration consistency across your hosts. These basics trip up even the most seasoned pros. So instead, here is your safe, four-step first response plan. 1. Define the scope. 2. Check the basic health and visibility. 3. Isolate the problem down to either the host path or the backend. And 4. Always verify the fix. Make sure the problem is actually gone and that your solution didn't create a new headache. You see the theme here, right? The most crucial point is this. Forget heroic guesswork. Your single best tool in a storage emergency isn't some fancy software. It's a systematic, repeatable approach. It keeps you calm and gets you to the root cause way faster. And remember, that approach has to be tailored. For vSAN, your system relies on looking at those cluster-level signals, things like health, compliance, and resync activity. For external storage, it is all about investigating those end-to-end path signals, visibility, protocol state, and multipathing. And that really leaves us with one final question for you to think about. Take this playbook and use it not just to fix things, but to actually improve them. Ask yourself this. Is your system just working today, or is it truly resilient for tomorrow? The difference between those two things? Well, it's all in the process.